All right, the third thing we're going to look at in this chapter is binomial probabilities, you guys. Binomial probabilities look at situations where you're trying to count an exact number of events for situations that can happen or cannot happen. All right? So if you're flipping a coin, it's a heads. We're looking at probability of exactly 5 heads. If you're rolling a dice, we're looking exactly at 4 occurrences of the number 5 in 27 trials. Okay? So binomial theorems, or binomial probabilities, you have a set number of trials. You have probabilities that do not change from trial to trial. And the probability of success and failure add up to 100%. It happens or it doesn't happen. All right? We have this formula up top. You can kind of look at it and see. All right? It's going to be the same thing every single time. Okay? So let's just dive right into the first result, or the first example. When we're looking at this, it says example 4, like finding a specific probability. At a telemarketing company, 15% of Jenny's calls end up in a sale. So that's going to be our P, our probability of success. All right. If she makes 20 calls in an hour, that's going to be my N, my number of trials. What is the probability she closes the deal on exactly 5 calls? This is going to be my X in my case. X is going to be the number of successes in your event. All right? So what we do is we're using combinations to figure this out, because the order of those sales doesn't matter. She doesn't have to make the first 5 sales and then fail 15 times. Right? We have to take into account all of those situations. So we use combinations to help figure that out. So we have 20 trials, and she wants to make 5 sales. At this point then, what are the chances she makes exactly 5 sales? Well, it's 0.15. She has a 15% chance of making a sale, and we raise it to the 5th power, because there's obviously, if you think back to independent and dependent events, we multiply probabilities together. This would be, however, that we make 5 calls directly in a row. The combinations out front allows us to take into account that order does not matter. All right? Well, if she has a 15% chance of success, her chance of failure is 85%. And then we need to ask ourselves this one question. If she has 5 sales in 20 trials, how many failures does she have? Well, she's going to have exactly 15. Remember, your probability of success and failure have to add up to 1, and your powers should add up to the total number of trials in each situation. At this point, I can use my calculator. I could type in 20 choose 5 times 0.1 to the 5th times 0.85 to the 15th. You wind up with 0.103. So she has a 10.3% chance of making 5 sales in 20 calls. All right, let's dive into the next one. What's the probability he gets at least 3 correct on a 5-question test? We're looking at a true-false situation. All right, so in a situation like this, at least 3 means 3, 4, or 5. So what I have to do is I need to account for all of those situations, and then like we did before, we're going to add them together. All right? So I need to set up the binomial probability, getting at least 3 correct. So we have 5 choose 3. Well, he has a 50% chance of getting it right. He wants 3 correct. If he gets 3 correct, he must get 2 wrong. So that's going to be the probability he gets exactly 3 correct. Then we set up the binomial probability, getting exactly 4 correct. If he gets 4 correct, he needs to get 1 incorrect. And then we have 5 choose 5, 50% to the 5th, 50% to the 0. All right? That would be he gets all 5 correct. Then we add those 3 situations together, and we wind up with, surprisingly enough, there we go, 0.5 or 50%. Okay? Not all situations are going to work out that way. Keep in mind The situations you could have on a 5-question test are 0, 1, 2, 3 right, 4 right, or 5 right. Okay? So in this situation, assuming all probabilities are distributed evenly, it makes sense that it is 50%. You just want to be cautious about that and running under that assumption, because that's not always going to be the case. All right? The final situation, we're going to use complements to help solve, because Mike needs one more point for an A this quarter. What's the probability he scores at least a 1? All right? At least a 1 means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, I don't know about you, but I don't want to add those 10 probabilities together on my own. What other situation could I look at? Well, the other situation that's available is 0. If I add up all these probabilities, it should add up to 100%, correct? So instead of calculating all of these, I'm going to use complements. So I'm going to subtract the probability he gets nothing correct, and I'm going to subtract that from 1. That's going to be equivalent to the sum of all 10 of those binomial probabilities. So we set it up. He gets 0 correct. Not doing so hot on this true-false test. And then he gets 10 wrong. We wind up with 0.999. So based on this information, 99.9% chance it's looking like Mike will get at least 1 correct, which means he'll get an A this quarter. So again, you can add up the probabilities separately, just like we did on part A for the events. Or if it gets to be too many probabilities, like on part B, to add together, you can add the complement event, keeping in mind that all of the events added together should add up to 100%. Either way, you would get the exact same thing. So if I took the 10 choose 1, 10 choose 2, 10 choose 3, 10 choose 4, 10 choose 5, 10 choose 6, 10 choose 7, 10 choose 8, 10 choose 9, 10 choose 10, if I added all those probabilities together, I would get 0.999. And that's it. Good luck.